Ahoy, nautical navigators! It's Justin and Mia again, and this time we found some other even cooler maps on board. It looks like there's some treasure to be found around here. Whoa, slow down, Mia. I know it's exciting to think about all the things we are going to buy with this treasure, but we gotta find it first. Good thing we know all about number lines, right? This one looks like it's scaled by... Ooh, wait a second. It looks like we'll be using fractions here, not just integers. In order to go treasure hunting and use our new map, we'll need to use what we already know about fractions, decimals, and number lines. We'll learn about a new category of numbers, rational numbers, and we'll use rational numbers to find the treasure on our maps. By the end of this lesson, you'll be able to explain what rational numbers are and plot all sorts of different rational numbers on the number line, including values between the labeled tick marks. Let's go treasure hunting! So, this treasure map that we found will be completed with a variety of rational numbers. But what does that mean exactly? Rational numbers go beyond integers, but how? Here are some examples and non-examples of rational numbers. What do you think the characteristics of rational numbers might be? Rational numbers are positive and negative numbers that can be represented as fractions with integers in both the numerator and the denominator. The only exception is that the denominator can't be 0. This also includes mixed numbers because they can be rewritten as improper fractions with integers. You can tell a decimal is rational if it is a terminating decimal or a repeating decimal, because these types of decimals have an equivalent fraction form. Rational numbers also include integers. For example, the integer 6 is also a rational number and can be expressed as the fraction 6 over 1, or 12 over 2, among others. Can you think of any integers that aren't rational numbers? You can't. All integers are rational numbers because they can all be written as a fraction. Even 0 can be written as 0 over another number. Take a second here to write down 3 examples of rational numbers in your guided notes. Rational numbers are great for allowing us to create more zoomed in and detailed scales. Using what you know about fractions, can you complete the scale on the right side of the 0? Pause while you work. If there are 3 tick marks between 0 and 1, separating the interval into 4 equal parts, we need to label each tick mark by fourths. That would make the first value to the right of 0 1/4. You can use fractions or decimals for your scales as long as you're consistent throughout the entire number line. For now, I'll be using fractions. Let's keep going. The next tick mark right in the middle between 0 and 1 would be 2/4, or 1/2 if you simplify. Then it's 3/4. Now, let's check out the left side of this number line. It's important to remember that on the negative side of any number line, the scale stays consistent. We work our way to the left from 0. You could think of scaling the negative side as marking the distance each tick mark is from 0, and using the negative sign to say that it's on the left side. That means the first tick mark to the left of the 0 would be negative 1/4. Notice that both positive 1/4 and negative 1/4 are 1 tick mark away from the 0. The only difference is that the negative sign tells us we're on the left side of the 0. The second tick mark would be negative 2/4 or negative 1/2. Again, it's the same distance from 0 as positive 2/4, just on the left side. What value does that third tick mark represent? That's right, negative 3/4. Now that we've gotten comfortable with the scales on these new maps, let's practice plotting some values. For example, we have a clue directing us to a treasure chest 9/4 miles behind us. But this number line map is scaled by halves. You got this though. Start by converting the improper fraction to a mixed number or decimal. Pause the video and try plotting that point. When I have to plot a fraction on a number line, I like to ask myself two questions. Which two integers is this fraction between? And is the fraction closer to one of the integers or right in the middle? Before we answer those questions, first, we can identify which side of the number line we'll be plotting this point. Because the treasure is behind us, the 9/4 is negative. And because it's negative, we'll plot it to the left of the 0. Now, which two integers is our treasure between? To figure this out, it might be helpful to convert the improper fraction to a mixed number or a decimal. So let's start with that. Negative 9/4 is equivalent to negative 2¼ or negative 2.25. If we had a value of positive 2¼ we know it was between 2 and 3. Even though negative numbers move in the opposite direction on the number line, we can follow the same thinking here. That means that negative 2¼ is between negative 2 and negative 3. Then we ask ourselves, is negative 2¼ closer to negative 2, closer to negative 3, or right in the middle? Well, the middle point would be negative 2½ so the treasure won't be there. A quarter is a smaller piece of a whole than a half is, no matter which side of the number line we're on. So just like how positive 2¼ would be closer to 2 than to 3, negative 2¼ is closer to negative 2 than it is to negative 3. That means our point will go right about here. Ha! Nice try, pirates. We've got one more clue, this time for a map with no extra tick marks at all. The clue says the treasure is 1.6 miles, or 1 6/10 of a mile, behind us. I know that would be negative, but where exactly does the point go on the number line? Pause the video and try plotting the point on your own. Just like our last clue, because the value we're plotting is negative, the point will go on the left side of the number line. If we were plotting on the positive side, the point would go between 1 and 2, so negative 1.6 will be between negative 1 and negative 2. The halfway point between those two integers would be negative 1.5. 6/10 is a little bit closer to a whole than 5/10 or a half, so our point and the treasure would be closer to negative 2 than negative 1. What do you think? Does this point look like a good representation of negative 1.6? I think we went a little too far toward the negative 2 here. Even though negative 1.6 is closer to negative 2 than negative 1, it's only a little bit closer, since negative 1.6 comes right after negative 1.5 when we count by tenths. So putting the point here instead would be more accurate. Let's practice plotting a few more points. On the number line below, plot the points negative 7/4, negative 0.9, and 2 1/3. Pause the video while you work. It may have been helpful to first convert all of the given points into the same form, whether that was fractions or decimals, to help you figure out which two integers each point should go between, and which one it would be closer to. First, -7/4 or -1 3/4 goes between -1 and -2. But it is closer to the -2 because 3/4 is a larger piece of a whole than 1/2 is. -0.9 is between 0 and -1, but it's much closer to the -1. Almost right there, but not quite. Your point for -0.9 should be closer to -1 than your point for -7/4 is to -2. Finally, 2 1/3 is between 2 and 3, but a bit closer to 2. You may have even visualized splitting that interval into thirds. Nice work! Fantastic work, explorers! You did an excellent job building number lines and plotting points with fractions and decimals. And we found that glorious treasure along the way. All this ocean exploring has got me in the need of some serious relaxation, though. Oh, great idea, Mia! Let's head toward the beach! Once we're there, we'll use everything we've learned about number lines to write inequalities comparing different rational numbers. Until then, don't spend all your treasure at once. See you next time! Hey.